In this example, we'll be finding the function values of angles. The terminal side of an angle theta in standard position passes through the point 8, 15. Find the values of the 6 trigonometric functions of angle theta. Let's first draw an angle theta that has the point 8, 15 on its terminal side. So 8, 15 would be approximately maybe here, and we'll label that as 8, 15. Now we'll drop down the perpendicular to form a right triangle. This is our angle theta, and that means that this side is 15, this side is 8. That's our value of x equaling 8, y equaling 15. Of course, we want to find the value of r, which is the hypotenuse of this right triangle that we've drawn. To do that, we use x squared plus y squared equals r squared. And therefore, 8 squared plus 15 squared equals r squared. That's 64 plus 225 equals r squared. Then I'm going to rewrite this over here with r squared first is equal to the sum, which is 289. And now we take the square root, and we only need the positive square root, of course, because it's a distance. So it's positive the square root of 289, which is positive 17. Now, that's the information we need. R is 17. I've redrawn that on the next sheet so that I have more room to find the values of the 6 trigonometric functions. So let's take a look at that. I have my angle theta. Then I have my point 815 showing that x is equal to 8, y is equal to 15, and r is equal to 17. And now I can set up my ratios for the 6 trigonometric functions, starting with sine theta. Sine theta is, of course, y divided by r. So when we look here, we have 15 divided by 17. So sine theta is 15/17. For cosine theta, that's equal to x over r. So x is equal to 8. We just said earlier that r is equal to 17. So cosine theta is 8/17. Tan theta. Tan theta is equal to y over x. And so that is equal to y, which is 15, over x, which is 8. So tan theta is 15/8. Now let's look at cosecant theta. Cosecant theta is also the reciprocal of sine theta. It's r over y. And then that would be equal to 17 over 15. For secant theta, that, of course, is the reciprocal of our cosine. That's r over x. And so that would be equal to 17 over 8. And then for cotangent theta, that's equal to, again, the reciprocal of tan theta, which would give us x over y. And so that is equal to 8 over 15. And those are the values of the 6 trigonometric functions for angle theta. In this example, we'll be finding the function values of an angle. The terminal side of an angle theta in standard position passes through the point -3, -4. Find the values of the 6 trigonometric functions of angle theta. So let's start by drawing angle theta in standard position. So here we have our axes, and we have the point -3, -4. And let's label that -3, -4. We know that the terminal side of angle theta passes through that point, and so theta would be this angle. Let's now draw a right triangle and label its sides accordingly. This would be the side for x, -3. This side would be -4. We are interested in finding r because that is the hypotenuse of the triangle, and we need that in order to find the values of the 6 trigonometric functions. So we use the Pythagorean theorem. X squared plus y squared equals r squared. X, of course, is -3, so it's -3 squared plus y is -4 squared, and that's equal to r squared. So we would have 9 plus 16 equals r squared. Then 25 equals r squared. Since r represents the hypotenuse of this particular triangle, we're just going to deal with the positive root of 25. So r is equal to 5. Now we can find the values of the 6 trigonometric functions, which we'll do here. I've drawn at least a cutout version of the triangle so that we have our sides, including the hypotenuse, our value of x, -3, y is -4, and r is 5. So now we find sine theta. Sine theta is equal to y over r. So y is -4, r is 5, so it's -4/5. Cosine theta is equal to x divided by r. So that would be -3 over 5, -3/5. Tan theta is equal to y over x. That would be equal to -4 over -3. Negative divided by negative is positive, so tan theta is 4/3. For cosecant theta, that's equal to r over y. That would be 5 over -4, or -5/4. Now let's find secant theta. Secant theta would be r over x. R is 5, x is -3, so it's -5/3. And now for cotangent theta, that's equal to x over y. X is -3, y is -4, and so negative over a negative is positive. So cotangent theta is 3/4. Those are the values of the 6 trigonometric functions for angle theta. In this example, we'll be finding function values of an angle. Find the 6 trigonometric function values of the angle theta in standard position if the terminal side of theta is defined by the line x plus 2y equals 0, where x is greater than or equal to 0. Now, the first thing that we'll want to do here is to find a specific point that lies on the terminal side of theta. That means the point must satisfy the equation x plus 2y is equal to 0. X has to be greater than or equal to 0. We'll just arbitrarily pick a value of x. Let's pick x equals 2. So if x is equal to 2, now we can solve for y. We would have 2 plus 2y equals 0. And that means 2y is equal to -2 when we subtract 2 from each side. And finally, dividing both sides by 2, we have y is equal to -1. And so the point that lies on the terminal side is 2, -1. Let's draw that. So we go out to 2, down 1. So this is the point 2, -1. Let's draw the terminal side. going through that point. And now let's create a right triangle by bringing up a perpendicular, labeling our sides 2, and of course, not the side itself, but that goes down to -1. Now, we need to find r, and we'll do that by using the Pythagorean theorem. We would have that r squared is equal to x squared plus y squared. And, of course, x is equal to 2. So it's 2 squared plus y, which is -1, -1 squared. That's our r squared. That means r squared is equal to 4 plus 1. Therefore, r squared is equal to 5. And then we take the square root of both sides, and we only want the positive root because it's representing r here, so it's positive the square root of 5. Now we have all the information we need to find the 6 trigonometric functions, so let's do that here, where I've drawn the equivalent right triangle, and I've labeled each of these sides corresponding to x equals 2, y equals -1, and r equals the square root of 5. So now for sine theta is y divided by r. So that's going to be -1 divided by the square root of 5, -1 over the square root of 5. However, we need to rationalize the denominator, and that means multiplying by the square root of 5 over the square root of 5. That would give us the result for sine theta is equal to negative the square root of 5 over 5. When we rationalize denominators from here on out, I'm going to shortcut the method because you now know that the method is to multiply the top and bottom so that you get a perfect square in the denominator. Let's take a look at cosine theta. Cosine theta is x over r. X is equal to 2. R is equal to the square root of 5. So that would be 2 over the square root of 5, which when we rationalize the denominator would be 2 square roots of 5 over 5. Now let's take a look at tangent of theta. Tangent of theta is equal to y over x. So the y value is -1, the x value is 2, so that would be -1/2. Now let's take a look at cosecant theta. Cosecant theta is r over y. That would be equal to the square root of 5 over the y value, -1, so negative the square root of 5 when simplified. For secant theta would be equal to r over x. So that would be the square root of 5 over 2, so square root of 5 halves for the secant. And finally, for cotangent theta is x divided by y, so that would be 2 divided by -1, and when we simplify that, it's -2. So those are the values of the 6 trigonometric functions for the angle theta. In this example, we'll be finding function values of quadrantal angles. Find the values of the 6 trigonometric functions for an angle of 90 degrees. Let's begin by drawing the angle of 90 degrees. So, of course, it's this angle that lands us on the y-axis. And we can select a point, for example, 0, 1. And now we know that x would be equal to 0, y would be equal to 1, and r would also be equal to 1. And I've written those three values on a new sheet where we can find the function values of the 6 trigonometric functions, starting with sine of 90 degrees. Well, the sine is equal to y divided by r. Y is equal to 1, r is equal to 1. 1 divided by 1 is 1. For the cosine of 90 degrees, that's equal to x divided by r. X is equal to 0, r is equal to 1. 0 divided by 1 is 0. Now for the tangent of 90 degrees. The tangent of 90 degrees is y divided by x. Y is equal to 1, x is equal to 0. And of course, 1 divided by 0 is undefined. Now let's find the cosecant of 90 degrees. Cosecant of 90 degrees would be equal to r divided by y. R is 1, y is 1, so the cosecant of 90 degrees is 1. Let's now find the secant of 90 degrees, which is equal to r divided by x. That would be 1 divided by 0, which is also, therefore, undefined. And last, the cotangent of 90 degrees is equal to x divided by y, which would be 0 divided by 1, which is equal to 0. Those are the 6 trigonometric function values for 90 degrees. Let's work another quadrantal angle. We will find the values of the 6 trigonometric functions for the angle theta in standard position with terminal side through -3, 0. Let's draw where -3, 0 is to begin this problem. So we have our axes, and -3, 0 is going to land us here. Now in this case, we have x equals -3, y equals 0, and of course, r is equal to +3. I've transferred those values to a new page where we'll find the 6 trigonometric function values for that angle theta, starting with sine theta. Sine theta is equal to y divided by r. So in this case, y is 0, r is 3. 0 divided by 3 is 0. For cosine theta, it is equal to x divided by r. X is -3, r is +3. That would be -3 divided by 3 for -1. For the tangent of theta, that is equal to y divided by x. That would be 0 divided by -3, and of course that's equal to 0. Then cosecant theta, which is equal to r divided by y, so that would be 3 divided by 0. 3 divided by 0, of course, is undefined. Next, we'll find the secant of theta. Secant of theta is r divided by x, which would be equal to 3 divided by -3, which equals -1. And the cotangent of theta is equal to x divided by y, which is equal to -3 divided by 0, and that is undefined. So those are the 6 values of the trigonometric functions for the angle theta.